But when you do that, you are bringing in hot air from outside. All right? At the same time, you are going to throw out the cold air from the room. So by having this energy recovery system, you can recover some of the energy that is used to cool down the room, and you can save some energy because of this ventilation. All right? So from during the MCO time until now, we have been promoting and we've been asking our customers to use this kind of ventilation products to help to combat the pandemic situation. All right? So these are some of the things that have been shown to you just now. Now, I'll move on. Next topic is on the net zero energy building. This is also another big thing happening, probably another mega trend, probably. Net zero energy building means the building which will able to offset any of the energy that is used by the building. It's roughly what you generate equals to what you consume. At the end of the day, you become net zero. The graph on the right will show a typical electricity consumption index. It's measured in kilowatt hour per square meter per year. All right. So the 3 bar charts there shows the normal building on the first line on the left, normal building. So this is a typical building. So you take any building in Kuala Lumpur or in Penang or Singapore, whether you will get roughly about 200 over kilowatt hour per square meter per year. In our MS 1525 standard, we have specified a recommended value of 200 kilowatt hour per square meter per year, a normal value, without having gone through any procedures to reduce that yet. All right, so this is what we expect to be 200 benchmark. But if we are able to implement energy-saving measures, we can reduce this number. The government have implemented several buildings in Putrajaya and also some in Bangi, the Leo building and the Geo building. The Leo building is in Putrajaya, the Geo building is in Bangi. So they have able to reduce this index. Leo building is about 100 and the Geo building is about probably 70 plus. Because Leo building is able to have a lot of solar panels which are able to offset this power. And so they're able to reduce that power, the intensity of the energy. All right? So you can see if you want to achieve net zero, it's going to be even more tougher than what faced by Leo and Geo. Net zero we're talking about here, virtually zero. All right? So in Malaysia, we are still quite far away. All right? So this will be a challenge. To achieve this, we will need a very good level of technology to achieve this. And what I shared just now, those two technologies, only tip of the iceberg that we need to achieve this zero, right? Because this is not an easy goal to achieve. It's a very difficult goal to achieve, right? Any building which implement energy efficient measures can achieve 136 kilowatt per square meter per year, all right? And currently, at the moment, there are only about 389 registered green buildings in Malaysia under the GBI scheme. All right? And we need to have much more of this if we want to help the government to achieve the carbon neutral. All right? I think recently, I think last year, our Prime Minister announced that Malaysia is committed to become carbon neutral by 2050. To do this, we need to have many, many buildings which are able to comply and able to achieve, I won't say zero, but at least near zero building, maybe in the range of 70s or maybe even or below than that, right? It's a big challenge, but I believe that this could be the next wave of in the industry, in the HVAC industry, because we need to achieve this if we want to become carbon neutral, to be able to fulfill the 1.5 degrees Celsius maximum in global temperature that we need to achieve whole world. Malaysia has to play its part, and this is one of the things that we need to do. So lastly, to achieve this, we also need digitalization. Digitalization, I think the previous session we were talking about Industry 4.0, right? So this game also will involve digitalization 4.0, because to be able to achieve low energy efficiency, we need data. We need to have all the necessary sensors to get all the data and to able to do the necessary action plans, how we can reduce, how we can identify where are the weaknesses and then how to overcome these weaknesses. So it has to be a merger between building automation, sensors, and data analysis, which includes, of course, big data. Right, so these are few mega trends that the industry is going through right now. All right, and but unfortunately, this kind of net zero or kind of energy is not easy to achieve. I've been asked this question before. What is the difficulties of doing this kind of what are the challenge? What is the main challenge of achieving this net zero? The main challenge should be the mindset. I think a lot of people not only in Malaysia, all over the world, mindset is tidak apa, I don't bother. As long as I can make money, I don't bother. What will I get if I were to do this kind of things? Right? So this is one of the main hurdle of achieving green buildings, achieving this kind of green tech to be successful in Malaysia. Mindset. Right? Mindset in the sense that how do we balance the benefits versus what we need to invest upfront. It's always a balance point, your ROI and the investment that you put in together. Right? So I think we need to become more mature in this thinking, and we need a lot of promotion, need a lot of support, and need a lot of incentive from the government. These activities cannot succeed if there's no support from the government or no incentives from the government authorities to help us to push through this kind of program in Malaysia. All right. So this is some of the challenges that we are facing in regards to this green tech technology. So with that, I end my sharing. Thank you.
Thank you once again, Dr. Chin. Thank you once again. And you know what? Talking about mentioning about net zero and green buildings, this is my personal experience. Everyone knows Merdeka 118, Merdeka 118 building, which is our tallest in Malaysia right now. Everyone knows it, right? This building, in fact, I don't want to mention any party's name. In fact, it's already certified as a green building, and they approach us. This is mainly why, because myself, I'm based in Dubai, Middle East, and I do ESG funding. It is actually green tech funding. So when they approach us, they came with the idea of 118. I couldn't brain that a building was certified green, okay, at that point of time. This was beginning of the year. And just upon checking right now, let me read this to you because it's not only certified, but Merdeka 118 is the first tower in Malaysia that has achieved triple green platinum ratings. Wow, which is actually GBI, also known as GBI, okay, Green Real Estate Buildings, and also Green Real Estate GRE in the Leadership of Energy and Environmental Design LEED. That is something phenomenal for Malaysia itself, I'll be honest. Okay, so looking towards that, what you mentioned was true. Most of us, in fact, we just think of being sustainable, but we don't understand even the idea how to even start to go there. You know, like what you explained is that it's the small steps and the mindset that needs to change because everyone plays an important role. And I totally believe in that. Thank you so much. For those of y'all, we will be taking questions once again at the end of the session. Please just hold on to your questions. And without further ado, I would like to call upon our next speaker. That's none other than Dr. Kevin, which just flew in. In fact, his flight just arrived. Okay, all the way from DC in the US. Thank you so much for being able to come, Doc. Okay, the dice is yours. Please, a round of applause once again for Dr. Kevin here. Thank you.
Hi, everyone. My name is Kevin. So I'm from Thamlev. Today's topic is the case study on the business transformation through innovation and IP for green tech. Okay, so let's straight to the point. Okay, so the screen behind me is showing how today an electric vehicle look like. Okay, it is not just a car, a bike. It's actually built around the bike, the car, with a very complicated ecosystem. This is why Tesla has bigger valuation compared to BMW nowadays. Okay, so this is the ecosystem that we design. So, okay, when you look at the the diagram, we have a bigger chunk that actually contribute from carbon credit. Okay, so just now we talk about Dr. Chin talked about the net, the net carbon zero. So how to encourage corporations, individual to participate in carbon net zero. Actually, what is available now, the carbon credit, carbon offset, is a very powerful tool to encourage the people to march forward the final goal. Okay, so same as Thamlev. Okay, so right now our scooters or light electric vehicle like micro car, electric scooter, moped, motorcycle. Okay, we have a IoT device which actually to track various type of telematics data, okay, which one main purpose is to do carbon footprint tracking, okay. So all this data actually will be used to verify, okay, how valid is your carbon saving, okay. And this kind of validation is not what I say, not what you say. It's actually through prestige carbon body like Vera, okay. So they are the body to basically to verify the carbon credit, okay. And this carbon credit eventually can be traded in that we eventually need to get resolved. So what we are doing is we have formed a consortium with Hyundai, okay. So with Hyundai, with LG, okay. So we actually form a consortium. So within this consortium, of course, the consortium will involve Nano Malaysia, okay, to provide us the the graphene technology, nanotechnology. Later, our next slides, I will explain more on that, okay. So with this consortium, okay, so we are building a complete ecosystem, not just the technology, but also monetary-wise, okay. For example, when you buy a gas vehicle, okay, normally you have the resale value, but very sad, there is no resale value for electric vehicle, okay. So with this ecosystem, okay, we are closed loop, okay. The battery that we are leasing to our consumer, after 3 years, 4 years, we will recycle back and have Hyundai to back up the buyback guarantee. Then there will be a resale value for your electric vehicle, okay. So that build the baseline for the after sales and the resale value for electric vehicle. So we kind of closed loop, okay. So we not just sell a vehicle, okay. Look like we are actually building the full ecosystem, okay. The ecosystem even include the big data analysis, okay, because we collect a lot of this telematics data, okay, how to process them, okay, and how to march forward zero net carbon, even for big data analysis. Because you know, current most widely used AI technology is based on deep learning. Actually, deep learning consumes a lot of energy, okay. Data center actually consume heavy power, okay. So how we can resolve that by applying new technology, okay. That will be in the next slides, okay. So, so green. Okay, so this is our research and development strategy. For Thamlev, we are a startup. We are small size. We have a small team of R&D engineer. Of course, if we want to try to complete the whole technology development, is basically it's impossible. Okay, of course we need money, right, funding, but how we collaborate with talents, how we collaborate with universities, how we collaborate with a famous or big corporation is a key strategy for us to success as a startup to grow bigger and stronger. Okay, so our research and development strategy, we actually divide to 5 categories. Here I'm showing 4 only. Sorry for that. First is on the powertrain technology. Okay, this is what we actually collaborate with Hyundai. We kind of develop a new kind of motor. It's called planetary gear motor. So it's a combine of magnetic with the gear system motor, and it will achieve 35% improvement on power efficiency. So what is special on this motor is it is spike-based excite mode. Okay, we know motor is we need to provide current to the motor coil to generate the magnetic field. That's how the rotor will turn. So instead of convention, we provide a constant current. We actually provide spike currents. So with spike currents, which means we no need to always to consume power in order for the motor to run. So it's just an instant spike. So it actually how we can save power from there. So this kind of motor is especially good for high torque and low speed. So how we're going to apply this is we know Malaysia agriculture actually has a problem to get the gas access. Okay, so by applying this kind of motor, we actually can apply on agriculture purpose electric vehicle. So then those remote area, those farmers or farms owner or plantation owners, they can use this type of high torque, low speed electric vehicle for their farming purpose. Okay, then the second is on the graphene technology for energy storage. So what we mean by energy storage is battery. Okay, so this is what we work with University of Tennessee, where I come from, with Nano Malaysia. We actually have the consortium that Nano Malaysia collaborate with us to apply graphene material on the current EV lithium-ion battery. Okay, so one of the critical spec for lithium-ion battery performance is the energy density, okay, or the power density. So the more battery you can pack into one area, okay, it's more efficient. But the issue here is how to dissipate the excessive heat generated from the current. So graphene is actually a superconductivity material that can remove the heat, okay, fast enough. So that's why actually Nano Malaysia has come out with a graphene material to be applied on lithium-ion cathode. Okay, so for us, Thamlev as application engineering, so we will apply this technology into our future lithium-ion battery. Okay, then next is on the GaN. Okay, this is another hot topic because last year, Ministry of Finance has given a huge sum of research grant on GaN device application research. Okay, so now I see this third bullet. The GaN is actually the biggest game changer. Why? Because we can utilize GaN device to redefine the light EV charging standard. Okay, we know. So we need to develop this standard. Okay, so we work with Hyundai to come up with the standard. Actually, in previous slides, we call that a battery swap station. Okay, where we are actually filing the small power charging stations with Vera for the carbon credit methodology project. Okay, so this will incur a very high standard of how we reduce the power loss. Okay, so with the GaN device, actually we are kind of innovate the current power electronics topology. Okay, with GaN device, the characteristic of GaN that powerful than convention power MOSFET is it has much less RDS on to reduce the conductivity, the conduction loss. And it has insignificant of recovery charge, okay, that will reduce the switching loss. So from there, we expect actually using GaN device, we can definitely to improve 2 to 3% of the power efficiency for the charging standard. Okay, so this we are working with Hyundai, with UT and Vera in Malaysia. Okay, so this is what we are undergoing the research and development process to enable us to achieve the green technology IP creation. Okay, and at the end, okay, what I want to emphasize is we are a startup, okay? We have limited resources, limited fund, okay? But of course, we are creating very good sales now in US, okay? However, we still need to try to survive R&D within our limited budget. So that's why, okay, for long-term R&D development, such as 2 to 3 years' time, we are collaborate very tight with university, okay? And for us, Thamlev, we always think we are application engineering, okay? So we apply those advanced technology and immediately commercialize it and push into the market. And of course, for the company profit growing, and most important is for the social benefit as well. Okay, yeah. So I think that's it. Yeah.
Perfect. Thank you so much. Once again, a round of applause for Dr. Tam Kevin. Thank you so much. That was exciting. Okay, so we have just 2 questions coming online, but come again. Do you have any questions from the floor? Members of the floor, any questions? Not at all. So let me consider these 2 questions will be the last questions for the y'all. Okay, give me a minute over here. Okay, here you go. So this, I will address it definitely to Dr. Chin, to yourself, okay? That will be, what were the challenges in the program that you had before implementing where Daikin is today?
You mean before Daikin came in the picture?
Yes.
Oh, okay. Okay. Daikin took over us in 2006. So
Yep.
prior to that, we were under a local company. OYL, I told you, under the Hong Leong Group. So the main difference is, of course, the technical strength. Daikin has really been many, many years in Japan. They are very well known in the world. So when they acquired us, there was a transfer of technology from Japan to Malaysia to us. So that was one of the crucial advantage that we had after they took over. So before that, we were a homegrown Malaysian company. Something like my experience by Mr. David in Sena. We were in a similar situation. We are a Malaysian company. We developed the technology ourselves. So we were proud also. We developed the local flavor of the products that we had in Malaysia and also in ASEAN region. And then, but of course, when Daikin took us over, we were able to elevate our technology to a next level, all right? And probably that was the advantage that we had. So we had some rough goings during those early days. No one to teach us. We had to self-learn ourselves. We had to do a lot of try and error. But we were perseverant. We soldier on, and we achieve some level of success through all our hard work that we had last time. Yeah.
So the key word here is self-learn.
Correct.
Self-learn and push yourself until you are able to achieve it.
Yeah.
Okay, thank you. Thank you so much, Dr. Chin. And then this next question is definitely addressed to you, Kevin. Yeah, Dr. Tham. Okay.
And also industries to use more and more of such green tech. Having said that, green tech, okay, I come from the point of view of the building. Right? Green tech, which involves many, many players. I cannot say that I can do it alone with Daikin. No way. Because in the building, there are many, many systems working together. So if you want to have a green tech to be successful, companies have to work together. We cannot be in a silo. I just protect my own self. I don't bother about others. I think we need to open up. We need to cooperate. We need to embrace each other's strengths and weaknesses, come together and implement this technology in any building that we have. Talking about, there are many in the market now at the moment, many air conditioning, sensors, systems, all kinds of products, electrical goods even. So we need to have this connectivity among all these things. So I think now the government, I think now we are in the digitalization of IR 4.0, right? Talking about connectivity. So we need to connect all these dots together. So to enable to connect this together, every player, every manufacturer have to open up to allow this to happen. If I'm silo, I'm so into myself, I don't allow people to connect, then you defeat the purpose of that. So I believe that all companies should come together and work together to overcome this challenge. Yeah. Thank you.
Thank you. Thank you so much. So I guess the take-home message today from the whole idea of being green tech innovators are actually having an open mindset, collaborating with others, and you can't work in silos. The whole idea is everyone should be working as a team, even though in different industries, right? Perfect. Thank you so much. Once again, ladies and gentlemen, a round of applause for our two panelists here. Also for the last session that we are having here on the 6th of October for SRIE. That is Innovation Insights from Malaysia Top Green Tech Innovators.